welcome back, my fellow rocket scientists, to another 300 Seconds of Science. My name is Nicole Maxheimer, and on today's episode, we're going to be launching into the science behind rockets. Recently, I was able to co-host a class-canceled episode featuring the on-campus organization, the Akronauts. This group of students showed us a few things about rockets and their preparation for their upcoming competition. We even got to build our own bottle rockets.
Oh! It went off!
So, when were the first rockets invented? The first rockets that we know of were used in the early 1200s in China for war affairs. There were many advancements of technology throughout the years for the United States, leading to the first moon landing in 1969. The Saturn V rocket launched into space the first men to land on the moon: Michael Collins, Neil Armstrong, and Buzz Aldrin. While space exploration is amazingly complex, rocket science really isn't. Rockets are fairly simple, and like the Akronauts, you could also build and fly your own model. On a smaller scale, of course. There are only 4 main parts that combine to make a rocket: a nose cone, fins, the rocket body, and an engine. The nose cone should be rounded or bullet-shaped to minimize friction. The nose cone is where the guidance system and flight direction controls are held, along with astronauts, satellites, scientific instruments, and even explosives. Like fish, rockets have fins, but instead of using them to swim, rockets use their fins to fly straight. Without these fins, the rocket would tumble out of control. Fins are usually located at the bottom of the rocket body, which holds the propellant and the rocket engine. The structural system of the rocket body is made of lightweight materials, like titanium or aluminum. The rocket engine burns a combination of chemicals called propellant, which is made of fuel and oxidizer, inside of a combustion chamber. Without the oxidizer, the fuel wouldn't burn once the rocket reaches space because, well, there isn't any oxygen in space. The most complicated part of building a rocket engine is their fuel systems. That is why only 3 countries have actually ever put rockets with people on them into orbit. So how do rocket engines work? It all has to do with a reaction. Newton's principle states, to every action there is an equal and opposite reaction. When you throw a baseball, for example, your body will react by moving in the opposite direction of the ball. A rocket engine throws a mass in the form of a high-pressure gas in one direction in order to get a reaction in the opposite direction. The mass comes from the weight of the fuel that the rocket engine burns. Thrust is the force that moves any aircraft through the air and is created by the propulsion system inside of the aircraft. Before, we talked about the fuel and oxidizer, which are combined in a combustion chamber. Combustion is just another word for a chemical reaction between substances that generates heat and light. In this chamber is where the propellant begins to heat up, and once the combustion produces hot exhaust that passes through a nozzle and accelerates flow and produces thrust, the rocket will launch. There are 2 types of rocket engines: liquid rockets and solid rockets. In a liquid rocket, the propellants are stored separately and then pumped into the combustion chamber. A solid rocket is when the propellants are mixed together and then packed into a solid cylinder. Now that we have an understanding of how rockets work, how are they used? Early NASA missions used rockets built by the military and were used to send astronauts into space. NASA also uses rockets to launch satellites into space and probes into other worlds. There are also smaller sounding rockets that don't fully enter orbit that NASA uses to conduct scientific research. Well, that's about all the time we have to discuss rockets on this episode of 300 Seconds of Science. If you want to learn more, head on over to the University of Akron's YouTube page and check out our episode of Class Cancelled with the Akronauts. While you're at it, leave us a comment or send us a tweet. And don't forget to subscribe to 300 Seconds of Science on YouTube, follow us on Twitter, like us on Facebook, and send us some love on Instagram. I'm Nicole Maxheimer, and that was 300 Seconds of Science. And now you know, so go out, enjoy life, and stay curious.
This program was produced by ZTV at the University of Akron. Do you want to gain experience in video production, professional social media, or working with real clients? Visit the UA School of Communications online or follow us on social media to learn more. ZTV, make media, make a difference.